This is Johnny doing lab demonstration lab 8 for SRT521NAA. So I guess we can start with my first code, what I used to basically clean the data. It's sorry, forgive me, I'm just a little lightheaded here. So essentially this is what I used to clean the data set. The data set I used was the where is it? Yeah, so it was the first one, so UNSWNB15_1 CSV. Yeah, so essentially what I got this from your example. So essentially it's a statement to essentially try to convert the IP address column to an integer, and if it can't, then it will just basically say it cannot convert IP address and then return none. So I'm basically stating all the category columns, so the non-numerical columns here, and then I'm basically saying for those columns to essentially assign a unique value to each of the unique inputs within the cells. So that's what's happening there, and then here is where it's assigning the statement over here to essentially go ahead and change the IPs to integers. So here we listed the source IP and the destination IP. So it's going to convert to integer, and then this is basically saying to drop any NaN places, like NaN values that are there, to try to clean it up even more, and then it's going to save it as a cleaned CSV. So I can show you the cleaned CSV here. So this is what it comes out to. I mean, I added the headers manually myself from the features CSV that was on the website. But as you can see, it converted everything into integers. And for other things such as like attack cat, it assigned it unique values for the categories that it had before. Yeah, so there's like 6, 4, and so on and so forth. So then let's move on to my lab A.py. So this is all importing the stuff that I need for the code to work. So this entire section right here is me trying to clean the data again for some reason. Some of the values that are within the data set still come out as a string, or it's being picked up as a string, so I was basically trying to do that again. So basically we're starting off, or this is essentially I guess a function almost, but it's essentially trying to convert whatever value it is into float, and if it doesn't, just basically put a NaN value there instead. So it starts off by basically reading the data set that we created from earlier, and it's going to assume everything is string. And here is where we basically state the categoric columns that we specified before, and then convert into basically drop into also to drop into basically apply this. So again, give it an actual float value instead. And then this part is where it drops all the NAND, the NAND values. And then moving on, this is where it essentially turns it all into string, or tries to convert it into a string type. Moving on, this is where the clustering happens. So we set the range for the k values to be 2, 5, 10, according to the lab. And then we're basically, this is just a for statement, and then we're basically just saying that, or we're just applying the k-means here, and then we're basically just looping it through all the values up here, and basically making it do it 3 times, and then we're going to have it predict. And then the next part would be to essentially target the attack cat column, because this is going to be like our targeted variable, just because this is a pretty good representation of like what categorizes each points to be, because this is what this is the column that basically says what attack type it is. And then we're basically applying select k-best to find the best features for this target value, or sorry, target category or column, whatever you want to call it. And then we're basically going to transform it into our x and y. This part is basically getting the top features that were selected, and then we're getting all the features there, and then we're basically grabbing a score for each one of them, and then getting only the top 5 features with the largest scores. And then here is where we're just creating a bar graph to display it. And then sorry, my throat's a little dry. So for here, this is essentially where we're just creating a for statement for creating all of the graphs for the k clustering from before. So it's going to create 3 graphs as well. This is just selecting the color, the hue, and then we're basically grabbing all of those k values, so whatever the points got assigned to, like the clusters, like whatever cluster number they were assigned to closest to each point, it will be saved. And then we're set the data frame, and then we're basically saving it to a new CSV. So everything that we did to a new CSV plus our clean CSV. So I'll show you that, Ryan. Just give it a couple seconds, just because it's running through the whole cleaning process that I set at the beginning of the code. yeah, so this is the top 5 features in the score. So it was SLoad, DTCP, STCPB, DLoad, and SJIT. There, it should bring up the figures in a sec. Yeah, so it's loading. Yeah, so this is the cluster chart for setting it to have 2 clusters. So the blue would be cluster 0, and the green would be cluster 1. So this is clustering 5. As you can see, it's a little slow, but let me just give you the overall picture, the CSV that it saves it all to. So this is clean CSV, and then it adds on these 3 additional columns. So it's basically saying this point was assigned to clustered 1, but if it was clustered 5, then this one was assigned to 2, and then the next one was assigned to 6. And it's basically showing that for all of them and what clusters each point was assigned to. Yeah, so that's that. And that's cluster 10, yeah. And then the code should finish by writing it to that CSV that I just showed. So this is my Lab 8B Python. So again, this is just doing all the same thing. I mean, the thing that you should probably pay attention to is the correlation matrix. And then this is essentially setting it to a heat map. So I already have it ran here because my machine's really slow, but this is the correlation matrix. And then I have the heat map right here. But yeah, that's all I have for Lab 8. Unfortunately, just because I'm too sick to keep on trying, but I was running into many issues to where the algorithms and the learning module or learning model wouldn't take NaN values and string values, and I guess that's just my cleaning method not working very properly, or just me being very sloppy in the cleaning process. But yeah, that's everything I have.